All right. So today, we'll discuss questions regarding the waveguides. Okay, from various public sector jobs as well as GATE exam, and also included some bits from engineering services. Okay, that is also like a popular exam that students usually go through if you want to join in services. So the engineering services bits also have included because usual before almost before 3 years, waveguides was not there as a topic. Maybe not 3 years, maybe 4 years back or so. Waveguides was 4 or 5 years back. The waveguides and S parameters, and means the waveguides was a topic, but it was not considered. Mm, Means not bits were not taken from the waveguide topics usually because they were kind of advanced, and previously in the olden days the gate doesn't include the waveguide topics, but the engineering services has included waveguides from very way back. So in order to get more bits from this waveguides, I also taken bits from the engineering services exams. So let us see and start to solve these bits so that you can get some idea, because it might help you to solve the actual problems, the descriptive problems also. It gives you the concepts, right? Right. So let us start with the questions that are given in ISRO exams. So in the previous years, from the ISRO exam, uh, let us talk about. So this is a question given in ISRO 2010 paper. So the question asks for which mode of circular waveguide will have the lowest attenuation. So we discussed about it, right? The dominant mode is actually TE11 mode in a circular waveguide, right? But the lowest attenuation, I told you that T01 mode has the lowest attenuation because as the frequency increases, the attenuation actually drops. That happens for T01 mode. So this is a conceptual question. Okay. So and the answer is T01 mode, which has the lowest attenuation constant. Okay. So the next one is the true statement of wave propagation in rectangular waveguides filled in air. Okay. So there is a rectangular waveguide which is filled with air, and the question asks for which of the following is true. So the phase velocity is equal to the velocity of light in air. Okay, maybe it's not true because phase velocity will be exactly equal to the phase velocity of c when it's a transverse electromagnetic wave. So the phase velocity is more than the velocity of light, or the phase velocity is less than the velocity of light, or the phase velocity itself is undefined.
B.
So so the answer is B. Very good. So let us see how we get that. So ikkadentante, because the phase velocity is nothing but omega divided by beta. So for your waveguide, if you remember, the beta is nothing but square root of k square minus kc square. If you take k common, you get square root of 1 minus kc square by k square whole square. So k అంటే replace చేస్తే, for k it is omega square root of mu epsilon, because your free space, this is omega mu epsilon naught, and of course in the square root you get 1 minus kc by k, you it gets it as fc by f whole square, right? We have done this derivation. So if you remember, this 1 by square root of mu naught epsilon is nothing but c. So it is c divided by some number. Okay. So phase velocity is c divided by some number. If this number is greater than 1, then definitely phase velocity will be less than c. If this number is less than 1, then phase velocity will be greater than c. Definitely we can see that this will be a number which is less than 1, because we usually operate for a frequency which is greater than cutoff frequency, then only a mode can propagate. So when f by fc is a number which is or fc by f is a number which is less than 1, okay, then when you square and subtract it from a 1, you get a number which is less than 1. So when you take a square root of it, you get a number which is less than 1. So this becomes a number which is less than 1. So if this is less than 1, usually your phase velocity will be greater than the velocity of light. So don't worry, this is the phase velocity. It is not the information velocity. Never an information can travel more than the velocity of light. So the information velocity is given by the group velocity. Okay. So there is nothing wrong for your phase velocity to become more than the velocity of light. But if your group velocity is crossing more than the speed of light, then it's a mistake, right? So your option is B. Uh, Let us go to the next one. So of course, I think this is also kind of same thing. So a waveguide approaches as the wave frequency approaches or a cutoff frequency of the waveguide, the correct statement is. So right now we had the expression Vp is equal to c divided by square root of 1 minus fc by f whole square. Okay, so as you are approaching the velocity, or as you are approaching the frequency, I mean when f is close to fc, okay, so it is almost close to 1. You can see the velocity is almost tending to infinity. Okay, so I can say the phase velocity almost tends to infinity is the right answer, right? So as f is close to fc, so this number becomes close to 1. So as this is going to 1, then phase velocity will tend to infinity. So your answer is C. Okay. Okay, so here there is another question. So the electromagnetic wave which propagates through a rectangular waveguide with dimensions is given is, okay, means is an EM wave of which frequency. So they are asking you which of the following frequencies can actually propagate in this waveguide. అలాంటి వేవ్గైడ్లో ఏ ఫ్రీక్వెన్సీస్ ప్రాపగేట్ అవ్వగలవని అడుగుతున్నారు. సో టు నో దట్, so it's given A is 30 mm and B is given as 50 mm. So what is the first mode that can propagate in a rectangular waveguide? It's TE10 mode. So what is the cutoff frequency for TE10 mode? So the cutoff frequency is, you want the cutoff frequency, maybe I know the cutoff wave number, that is square root of m pi by a whole square plus n pi by b whole square. And so usually this is what I remember, because cutoff frequency is nothing but 2 pi fc square root of mu epsilon naught, mu epsilon. Okay, so if you have here free space, so then it is mu naught epsilon naught, and because I'm taking m as 1 and n as 0, so I get 2 pi fc square root of mu naught epsilon naught is equal to pi by a, right? So here pi gets cancels out, so your fc is simply 1 by 2a times of square root of mu naught epsilon naught. So this 1 by square root of mu naught epsilon naught is nothing but c. So c by 2a means if it is free space, in case the medium is free space, didn't give anything regarding free space into చెప్పలేదు. But if that is the case, fc is nothing but c divided by 2a. So it is 3 into 10 to the power of 8 divided by 2 into the dimension of a is given as 30 mm. Because అంటే ఇక్కడ T10 mode ఎందుకు చేస్తున్నాను అంటే, because in a rectangular waveguide the first mode that has to propagate is T10 mode. So right now I want to check whether a T10 mode can propagate at 4.5 or 5.5 or 50 or 30. So that is what I'm checking. So if I know the cutoff frequency, then I can estimate what mode can propagate and what frequency can propagate and what frequency cannot. So ఇక్కడ 30 mm అంటున్నాను కాబట్టి you get 10 to the power of -3 here. So what is the answer? So you get this, you get, so then 10 to the power of 7 into 5 అని రాసుకోవచ్చు. 2 cancels out. ఎంత నాన్న? So you get 50 gigahertz.
Yes, sir.
Okay, so your answer is 50 gigahertz. So the cutoff frequency is 50 gigahertz. So అంటే all modes below the cutoff frequency will not propagate. So this will not propagate. So this will not propagate. అయితే ఇక్కడ 50 కూడా ఇచ్చారు ఆన్సర్. Can I take 50? Can 50 gigahertz propagate?
అంటే అటెన్యూషన్ ఎక్కువ ఉంటుంది, అది ఫేస్ వెలాసిటీ.
No, it cannot propagate because at 50 what happens, because fc is exact equal to f అయినప్పుడు beta అన్నది 0 అయిపోద్ది. Okay, means when frequency is exactly equal to fc, we had this like k is become equal to kc square, right? So these two satisfy. If they satisfy, because beta square is nothing but k square minus kc square, right? So when these two become equal, k and kc become exactly equal at cutoff frequency, your beta goes to 0. So there is no propagation at 50 gigahertz. Okay, it is not even attenuation. There is no propagation also. So if 50 gigahertz is not going to propagate at all, so this frequency is not going to go. Only 300 gigahertz will propagate. Okay, so the answer is D. So this is 2012 question. So let us go to the 2013 question. So the question is, if a waveguide cross section of a square waveguide with the T11 mode propagating is gradually deformed into a circle, then the corresponding circular waveguide mode will be. Okay, so the thing here is, uh, so initially it was a uh, square waveguide. Okay, it's a square waveguide cross section, and what they have done is they have converted the square waveguide cross section into, they deformed it and they have somehow converted it into circular cross section. Okay, so మీన్స్ వాట్ కెన్ హ్యాపెన్ హియర్ అంటే ఇక్కడ ఇంతకుముందు T11 మోడ్ ప్రాపగేట్ అవుతుంది అంటున్నాడు, బిఫోర్ T11 మోడ్ ఈస్ ప్రాపగేటింగ్. సో వాట్ కైండ్ ఆఫ్ మోడ్ కెన్ పాసిబుల్లీ ప్రాపగేట్ in a circular waveguide? So that is a question. So
T10.
T10. Okay, so ఇక్కడ the propagation mode is gradually deformed into a circle, then the corresponding circular waveguide mode that will propagate. సో ఇక్కడ ఏంటంటే సర్క్యులర్ వేవ్ గైడ్ లో అసలు ఏ మోడ్స్ ప్రాపగేట్ అవ్వగలవు అన్నది ముందు మనం ఇనిషియేట్ చేసుకోవాలి. సో ఇన్ ద సర్క్యులర్ వేవ్ గైడ్, ఇఫ్ యూ రిమెంబర్, మనం TEMN మోడ్ తీసుకున్నాం, NM మోడ్ తీసుకున్నప్పుడు ఐ టోల్డ్ యూ దట్ TE00 ఎగ్జిస్ట్ అవ్వదు, అట్లానే TM00 కూడా ఎగ్జిస్ట్ అవ్వదు. అట్లానే TE01 కానీ TE10 కానీ దే బేసిక్లీ డోంట్ ఎగ్జిస్ట్. వై డోంట్ దే ఎగ్జిస్ట్? అంటే సారీ, T01 ఎగ్జిస్ట్ అవుతుంది, T10 తీసుకోలేదు. ఓకే, ఎందుకు తీసుకోలేదు అంటే 10 మోడ్ బికాజ్ మేబీ ఇట్ ఈస్ 0th ఆర్డర్ ఎగ్జిస్ట్ అవ్వదని. కానీ ఇక్కడ వీడు NM ఫాలో అవుతున్నాడా MN ఫాలో అవుతున్నాడా అన్నది వీ డోంట్ నో ఎట్. ఓకే, సో how do we decide what kind of mode is propagating here? అంటే the only way is to come attack this problem from the field's perspective. Okay, so they said it is a TE11 mode propagation, so you have half sinusoidal variation in both x direction as well as half sinusoidal variation in y direction. So your fields will be like okay, so your fields, the fields will be um, they will be like this. So maybe I can draw. So and as you move away from the center, okay, you can see that the field decreases as you go in this direction. As you go in this direction, so the fields will decrease. At the center you get a maximum. Okay, so such kind of field patterns uh, ఏ మోడ్కి వస్తాయి అన్న దాన్ని బట్టి we need to decide. Okay, so that is how you get the answer for this question. Or you might think maybe there is another way, like cutoff frequencies నుంచి can we get the answer అంటే from the cutoff frequency, because it's a square waveguide. For example, if I assume it's a square waveguide, so the cutoff frequency for it is uh, nothing but if I think it's an air-filled waveguide, it is C divided by square root of 2 pi. So m pi by a, so here m is 1, so you get pi by a whole square plus again pi by a whole square. Okay, so from the cutoff frequency you get a cutoff frequency. Okay, but you will not get this what um, we don't know whether when he deformed the circular waveguide into a cylindrical waveguide. Okay, what I can see is mostly when I deform a square waveguide into a circular waveguide, okay, what can be the diameter I can get? Okay, అంటే ఇలా అనుకుందాం. So let me take a square. Okay, and mostly I can make it a circle like this, or maybe I can make it a circle like this. If I want to. Okay, so those are the things I can do. So from there maybe I can estimate what kind of radiuses I can have and what kind of cutoff frequencies I'm dealing with. Okay, so what do you think is possible? What do you think, which mode is most possible to propagate? Maybe if we can approach it from the cutoff frequencies. Okay, maybe what I will do is I'll show you the mode patterns which we have seen already. Maybe from there you can get an idea regarding the answer. 1 minute. So T and part 2. Okay. Right. So these are the mode fields for the circular waveguide. Right. Circular waveguide mode fields చూసినప్పుడు these are the things which we have seen. Right. So in the circular waveguide, if you look at these mode fields, what I can say in the mode fields, um, TM11 mode అంటే ఎట్లా ఉందో చూడండి. TM11 mode అంటే it will have, I told you that it will have a symmetry of distribution on the upper and the half bottom half plane. అంటే ఇక్కడ phi అన్నది అంటే n అన్నది ఏంటి అంటే it talks about cos n phi factor in your circular waveguide. So if your n is made as 1, n 1 చేశారనుకోండి, that means what happens is you'll have one symmetry అంటే about one half plane you get a one symmetry. But if you make it 2 చేశారనుకోండి, if you make it 2, then you get symmetry in two half planes అంటే like maybe I cannot draw it here, but ఇక్కడ if you see TM02 అని తీసుకున్నాను అనుకోండి, so TM02 you can see that whatever pattern that repeats in this half plane అంటే half కూడా కాదు quarter plane లో ఏం ప్యాటర్న్ అయితే ఉందో సేమ్ ప్యాటర్న్ రిపీట్స్ హియర్ విత్ ఆపోజిట్ సైన్, అనదర్ విత్ డిఫరెంట్ ఫేస్ హియర్ యూ హ్యావ్ అండ్ విత్ డిఫరెంట్ ఫేస్ అంటే కాస్ 2 5 వస్తుంది అన్నమాట ప్యాటర్న్లో. సో ఇదైతే ఒకవేళ n1 తీసుకున్నాం అనుకోండి, ఇఫ్ n is taken as సారీ దిస్ ఇస్ n equal to 0, ఇవి nm మోడ్స్ కాబట్టి దిస్ ఇస్ ఫర్ n is equal to 0 కేస్. సో n is equal to 0 కేస్ యూ హ్యావ్ సిమెట్రీ ఎవ్రీవేర్. But whereas if you take n is equal to 1 case, it repeats one time. But if you take n is equal to 2 case, there is a symmetry or there are two symmetric planes now. Ikkada only n is equal to 1 తీసుకుంటే there is only one symmetric plane. So about the symmetric plane, the fields will be positive and negative on both sides. అది n is equal to 1 cos n phi plane లో తీసుకున్నప్పుడు. సో ఇక్కడ కూడా మనకి if you assume that T11 mode, so T11 mode in a స్క్వేర్ వేవ్ గైడ్, ఒకవేళ ఒక స్క్వేర్ వేవ్ గైడ్ తీసుకుంటే T11 మోడ్ ఫీల్డ్స్ ఎలా ఉంటాయని ఆలోచిస్తే, సో మేబీ I can take you back to the TE mode fields so that you can get the answer. So ikkada these are TM and TE case కి వెళ్తే, so let me go back. Right. So ఇవి TE mode fields నాన్న. So if I take a scenario where A is equal to B, ఇక్కడ A is equal to B కేసు తీసుకున్నాం అనుకోండి. So if I take a case where A is equal to B and if I assume that there are TE11 modes, TE11 modes ఉన్నాయని చూస్తే I can see that there is EX component and there is EY component. Okay, if I assume there is M is equal to 1 and N is equal to 1, so you can see that I get something cos m pi by A and sin pi y by B, and for EY component also there is sin pi x by A and cos n pi by B. Okay, so because here both A is equal to B, maybe I can write down these fields, what kind of fields I can have. So I can say electric field is some constant times. Okay, so your ex component is some constant j omega అదంతా some constant అనుకుందాం. సో of course అక్కడ ఒక j ఉంది కాబట్టి maybe write it as j times of some constant e naught times of uh, cos of pi x by a and sine of pi y by a, again because it's of same dimension. The other way you can think of the ey fields as minus j times of some constant. Okay, uh, some constant times of sine pi x by a and cos uh, pi y by a. Okay, so those are the fields I can get. Okay, so maybe I'll write it on this thing so that we can one second, I have to change the presentation. Okay, so if I write for a square waveguide, I have my x component as minus j times of some constant of cos pi x by a and sine pi y by a. Okay, so that is one thing I got. The other one is if I take ey component, it will be something like I get minus j times of some ey j times of some constant. I got sine pi x by a and cos pi y by a. Okay, so this is how my x and y components are. Okay, so you can see that if it is a square waveguide, a TE11 mode is propagating. So this is how the electric fields of x and y components will look. So they have cos variation along x direction and y variation means sine variation along y direction, and of course the y components also. So if I have to write the resultant magnitude, so if I have to write what is the resultant magnitude and how it is changing, okay, so the resultant magnitude will be uh, so here you basically have both x and y variations. So if you try to get it from the fields, okay, I can say that because there is cos variation and sine variation in x direction and sine and cos in y direction, so the fields are changing, like where is the maxima and where is the minima. So that is what I want to see. So what I can say is when x equal to 0, at x equal to 0, if I put x equal to 0 in this scenario, I can say that the field at x equal to 0, what is happening? At x equal to 0, this goes to 0. So you have only x component. So if I take this as x axis and this as y axis, okay, at x equal to 0, you have only x component. So at this edge, so edge the fields are pointing in upward direction, right? They have only x component. Okay, and what about the top at the bottom and the top edge? So if I put y equal to 0, I can see that if I put y equal to 0, there is no x component, there is only y component. So at the bottom the fields are like this. And what about the fields uh, at y equal to a? If I put y is equal to a, then you can see the y component goes to 0 now. Okay, but now what happens is if I put y is equal to a here, I mean if I put y is equal to a, again the x component goes to 0, but you have opposite direction ey components like this. Okay, so if I take this అంటే ఇలా చూడండి, అంటే ఇప్పుడు if I put x equal to a here, I will get a component x equal to a పెడితే నాకు నెగిటివ్ x direction లో కాంపోనెంట్ వస్తుంది. సో అంటే the components, if I try to plot the fields, what happens here, so at the edges the fields are like this. Okay, in opposite directions. And so if I try to deform this field into a circular waveguide, I need to have a field component which also goes like this. అంటే అప్పర్ హాఫ్ ప్లేన్లో ఎట్లానా లోవర్ హాఫ్ ప్లేన్లోనేమో ఆపోజిట్ ఉండి, ఓకే, అలాగే ఈ సైడ్ ప్లేన్లో కూడా ఏంటంటే ఇట్ హ్యాస్ టు బి లైక్ దిస్ అండ్ ఇట్ హ్యాస్ టు బి లైక్ దిస్ అగైన్. Okay, so I can see that there is antisymmetry in one plane and there is antisymmetry in the other plane also. So రెండు antisymmetries ఉన్నాయి కాబట్టి definitely it has to be a n is equal to 2 case. Okay, n is equal to 2 case ఉండాలి. అయితే ఇక్కడ n is equal to 2 కేసెస్లో 2 మోడ్స్ ఉన్నాయి. TE21 మోడ్ ఇచ్చారు, అట్లానే TE12 mode అని ఇచ్చారు. And basically the question does not clearly mention what convention they have used, whether they are using TENM కన్వెన్షన్ ఆర్ TEMN కన్వెన్షన్ వాడుతున్నారు అన్నది మనకు చెప్పలేదు. ఓకే, సో బికాస్ వీ డోంట్ హ్యావ్ దట్ thing here, maybe we'll take with a wild guess that maybe they are not using the convention of TNM because TMN mode convention వాడుతున్నారు కాబట్టి let us assume that if they are using a TMN mode convention. Okay, so here M and N indicates what అంటే here basically నేను ఆల్రెడీ చెప్పాను. So in always when NM or MN convention, the matter is always this number which you choose, the first number which you choose basically have to indicate your angle. అది ఎప్పుడు యాంగిల్ని ఇండికేట్ చేయాలి. ఓకే, నెక్స్ట్ నెంబర్ షుడ్ హ్యాస్ టు ఇండికేట్ ద ఫస్ట్ రూట్ ఆర్ ద సెకండ్ రూట్ అండ్ సో ఆన్. ఓకే, సో ఇక్కడ what I can see is there is two antisymmetric planes, okay, in the fields. So definitely you should have a factor of cos 2 phi la రావాలి. ఓకే, ఎందుకంటే cos 5 లాగా వచ్చిందంటే యూ షుడ్ హ్యావ్ ఓన్లీ వన్ యాంటీసిమెట్రిక్ ప్లేన్. అంటే ఏంటంటే పైన అంతా ఫీల్డ్ నెగిటివ్ ఉంటే కింద అంటే పైన ఫీల్డ్ ఒకవేళ ఒకటే యాంటీసిమెట్రిక్ ప్లేన్ అనుకున్నాను, ఎవ్రీవేర్ ద ఫీల్డ్ విల్ బి లైక్ దిస్. ఇలా ఉందనుకోండి ఫీల్డ్, దానికి ఆపోజిట్లో ఉండాలి ఎట్లాగా. బట్ అట్లా లేదు కదా, దేర్ ఈస్ ఆల్సో ఈ సైడ్ వాల్స్ మీద కూడా ఫీల్డ్స్ దేర్ ఇస్ అన్ యాంటీసిమెట్రీ. సో ఐ కెన్ సీ దట్ దేర్ ఆర్ టూ యాంటీసిమెట్రీ ప్లేన్స్. ఓకే, రెండు ఉన్నప్పుడు ఏంటి అంటే యువర్ n షుడ్ బి టేకెన్ as 2. So I can see that in this case the first number is taken as 1, whereas the first number is taken as 2 in this case. So that makes the answer as C. Okay, so that is how you can get it from the fields. Of course you need to have an idea regarding the fields, what kind of fields you have to solve this. But of course they didn't give it so that you have an idea on this analysis. But because practically most of the time when you use a square waveguide and if this guide is propagating, usually it shifts into TE21 mode. So on that basis they have given it. Okay, so this is how you can at least guess the answer and solve it. Okay, so it's basically a tough question. You need to have the idea regarding the field modes, what kind of mode patterns you have in a rectangular waveguide and all. Okay, so let's move on to the next question. So the next question is a rectangular waveguide with air medium has A given, B given, and it is fed with the 3 gigahertz carrier from a coaxial cable. Okay, some source it is given. Which of the following statements is false for TE01 mode? Okay, it's not TE10. They're asking for TE01 mode. Okay, so అంటే మీ ఆపరేటింగ్ ఫ్రీక్వెన్సీ ఇస్ 3 gigahertz అన్న. So what happens for TE301 mode ante, first of all we need to calculate the cutoff frequencies. Because it is said it is air filled, the cutoff frequency for TE10 mode is nothing but C divided by 2A, and the cutoff frequency for TE01 mode will be C divided by 2B. Okay, so let us try to find these cutoff frequencies. So can you tell me what is the cutoff frequency for TE10 mode? ఇక్కడ A value ఇచ్చాము, A is 22.86 mm and B value is 10.6 mm. Okay, so can you tell me what is the cutoff frequency for TE10 mode?
gigahertz.
So it's approximately 41 gigahertz. What is the cutoff frequency for TE01 mode?
141 సార్. దీనికా సార్ TE01కి 141 సార్.
Okay, TE01 is 141. Okay, and TE10 is 41 gigahertz. అలా వచ్చింది బై 2 వస్తుందేమో కదా, అదేలేండి బై 2 లేదు ఇక్కడ.
65 GHz.
52 గిగాహెర్ట్జ్. ఓకే,
65 సార్.
65. ఓకే, థ్యాంక్ యూ నాన్న. సో I can see that any mode cannot propagate through this. Okay, whether it is T10 or 01. Okay, so T is a non-propagating mode or propagating mode in case it is filled fully with a dielectric material of proper dielectric constant. Okay, సో ఏదన్నా డైఎలక్ట్రిక్ పెడితే అప్పుడు T01 మోడ్ ప్రాపగేట్ అయ్యే ఛాన్స్ ఉందా అంటే వీ డోంట్ నో, బికాస్ ఇక్కడ స్క్వేర్ రూట్ ఆఫ్ ఎప్సిలాన్ ఆర్ పెట్టాలి అంతే కదా. సో కెన్ ఐ, what should be the value of epsilon r if a 3 gigahertz has to propagate? T01 mode లో 3 gigahertz propagate అవ్వాలంటే epsilon r ఎంత ఉండాలి చెప్పండి. సో అంటే ఒకవేళ if it is filled with the dielectric medium, the cutoff frequency for T01 mode will be 3 by 2b by square root of epsilon r. అయితే ఏంటంటే this happens when fc of T10 mode is less than the cutoff frequency is less than 3 gigahertz. 3 gigahertz కంటే తక్కువ ఉంటేనే అప్పుడు 3 gigahertz అన్న ఫ్రీక్వెన్సీ T1001 మోడ్లో ప్రాపగేట్ అవుతుంది. సో ఫర్ దట్ టు హ్యాపెన్, C divided by 2b times of square root of epsilon r should be less than 3 gigahertz. Right? Can you tell me what will be the answer for square root of epsilon r in that case? అంటే epsilon r ఎంత అవుతుందో చెప్పండి.
సార్ ఇందాక అది 6.5 GHz, అది 14.1.
ఇది 6.5. ఓకే,
సార్.
ఇది 14.1.
Yes, sir.
ఓకే, థ్యాంక్ యూ నాన్న. ఓకే, సో బట్ ఎనీవేస్ ఇన్ బోత్ కేసెస్ 3 gigahertz is not going to work out. బట్ ఇప్పుడు వర్కౌట్ అవుతుందా అన్నది చెప్పండి. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఎంత ఎప్సిలాన్ ఆర్ తీసుకుంటే దేర్ ఇస్ ఎ ఛాన్స్ ఆఫ్ ప్రాపగేషన్. సో ఇక్కడ ఎప్సిలాన్ ఆర్ ఎంత ఉండాలి? సో లెస్ దాన్ కాబట్టి 3 గెట్స్ క్యాన్సిల్స్ అవుట్. హియర్ యూర్ గెటింగ్ 10. సో ఐ కెన్ సే స్క్వేర్ రూట్ ఆఫ్ ఎప్సిలాన్ ఆర్ షుడ్ బి గ్రేటర్ దాన్ 1 by 2b 10. అంతే. or if I square it I get 4b square of 100. ఎంత వస్తుంది వాల్యూ?
$22.25.
అంత పెద్ద వాల్యూ వచ్చిందా? ఓకే, బి స్క్వేర్ అంటే ఓకే అంతేలేండి. సో యూ కెన్ సీ దట్ if you have to make it, if you want to make this mode propagate, you basically have to use a propagation constant which is enormously, means you need a dielectric medium which is enormously big. epsilon r అంటే 22.5 కావాలంటే, so which is not practically possible. Okay, so I can say that T01 mode is basically a non-propagating mode in our case here. Okay, so
C రైట్ అవ్వచ్చు కదా సార్?
అవ్వచ్చు. అంటే ఒకవేళ ఆ టైప్ ఆఫ్ డైఎలక్ట్రిక్ కాన్స్టెంట్ అన్నది మన దగ్గర ఉంటే డెఫినెట్లీ C is a possible answer. Okay, so maybe check what is Acha, so the question is actually which of the following is a false statement. Okay, so we are not looking it in the right way. Okay, so which of the statement is false statement? Okay, so T01 is definitely a non-propagating mode. Okay, మీరు అన్నట్టు ఒకవేళ epsilon r 22.5, it is not feasible actually, but it is possible. If you can find a dielectric like this, then maybe you can make it a propagating mode. So this is also possible, but what is not possible is to make it a propagating mode right now. అంతే కదా, ఇప్పుడు అది ప్రాపగేటింగ్ మోడ్ అయితే కాదు, ఎందుకంటే ఫర్ దిస్ గివెన్ సినారియో the cutoff frequency of it is 14.1 gigahertz, so it will not propagate. So So which of the following is false statement అంటున్నాడు. So if you call this mode as a propagating mode, that is a false statement, right? So can you call it a non-propagating mode ante is it a false statement ante? No, it is true, it is non-propagating. You can make it propagating if you can change the dielectric constant, so this is also true. So the only false statement is A. Okay, so the answer is it is a propagating mode, right? Sorry, I didn't see that they're asking for false statement. So then true statement ఏంటని వెతుకుతున్నా. Okay, so the next question is TM01 mode in a rectangular waveguide. TM01 అంటున్నాను. Do you think it can exist? So what is the answer for this?
Evanescent modes. Non-existent.
Non-existent. Very good. It is not even evanescent mode. ఎందుకంటే evanescent అంటే కట్ ఆఫ్ ఫ్రీక్వెన్సీ కంటే తక్కువ ఉంటే దెన్ యూ కాల్ ఇట్ ఎస్ evanescent మోడ్స్. బట్ బేసిక్లీ వి సా ద TM01 సొల్యూషన్ అన్నదే ఎగ్జిస్ట్ అవ్వదని చూసాం. ఓకే, TM01 కానివ్వండి, TM10 దే డోంట్ ఎగ్జిస్ట్. సో ద ఫస్ట్ వన్ ఈస్ TM11. సో యువర్ ఆప్షన్ ఇస్ సి. Okay, so we'll go to the next one. So two rectangular waveguides have dimensions 1 centimeter by 0.5, another one has 1 centimeter by 0.25. Their corresponding cutoff frequencies. Usually when they don't mention the mode, it is they're asking for TE 10 mode. Okay, so they're basically asking for TE 10 mode, but you can see that they didn't change the dimension of A here. Okay, so I can straight away tell the answer is what? So that is 15 and 15 gigahertz. Just for the purpose of B అవుతుంది అంటారా ఆన్సర్?
D sir, అంటే C/2A కదా సార్.
ఓ C/2A, సారీ ఐ డెంట్ సీ ఇట్. ఓ వీ నీడ్ టు క్యాలిక్యులేట్. ఇక్కడ 30 కూడా ఇచ్చారా? ఓకే, ఓన్లీ ఒకటే ఉంది అనుకున్నా. ఓకే, సో 30 కూడా ఉంది కాబట్టి C/2A కాబట్టి, సో ఇఫ్ యూ టేక్ 1 centimeter then your answer should become option D. Okay, so
అంటే ఆప్షన్
so
C
you
సార్.
got that. So let us see.
సార్
Oh,
C 15
C
కదా.
నేనా? Oh, okay, 15
అంటే
వచ్చిందా?
1.5.
Okay, anyway, so it's better I calculated. 1.5 వస్తుందా? So C divided by 2A is the answer. So C is 3 into 10 to the power of 8 divided by 2 into A is given as 1 centimeter, so 10 to the power of minus 2. So that means the answer is C. Okay, right. Okay, so we'll move on to the next one. An air-filled waveguide R1 is operating at a frequency of 2 gigahertz and another air-filled waveguide R2 is operating at 4 gigahertz. The guided wavelength of these waveguides at their respective frequencies are equal. Okay, so so the first waveguide is operating at a frequency of 2 gigahertz, Nana, and the second waveguide is operating at a frequency of 4 gigahertz, but they are saying the guided wavelength of the first waveguide, the guided wavelength of these waveguides at their respective frequencies are equal. So at these two are equal, guided wavelength. If the cutoff frequency of the first waveguide FC is 1 gigahertz, so they're asking what is the cutoff frequency of the second waveguide. First of all, what do you mean by guided wavelength? So wavelength veru, guided wavelength. So lambda ante we know that lambda is nothing but wavelength. Okay, what do you mean by guided wavelength? So guided wavelength ante, so in the waveguide, so because if you take a waveguide, as I told you, ఈ waveguide ని two types లో చూడొచ్చు. You can think of it as a wave bouncing off, or you can think of a wave that is traveling in z direction, a non-uniform plane wave traveling in z direction. అయితే when I say a wave is traveling in z direction, ఆ z direction లో if a wave is traveling in z direction, in that direction what is the propagation constant? Beta is the phase constant, and of course if there are no losses, beta becomes a propagation constant. So beta is the phase constant that you have in the z direction. But I told you that what is k? K ఏంటి అంటే in case if there is no waveguide walls, అంటే waveguide walls ఏమి లేకపోయి ఉంటే, అంటే బౌండరీస్ ఏమి లేకపోయి ఉంటే, if you are dealing in an unbounded medium, then the wave would have traveled with a phase constant of k. where k is nothing but omega square root of mu epsilon. So lambda అన్నది ఏంటంటే ఇట్ ఈస్ అకంపెనీడ్ విత్ దిస్ వాల్యూ k. వేవ్ లెంగ్త్ అన్నది ఏంటంటే ఇన్ ఫ్రీ స్పేస్, ఫ్రీ స్పేస్ అని కాదు, ఇన్ అన్ అన్బౌండెడ్ మీడియం ఇఫ్ వేవ్ ఇస్ ట్రావెలింగ్ then we define the wavelength as c divided by the velocity divided by frequency kabatti that comes from this equation. But because in the waveguide, if you walk along the z direction ante waveguide ela unnappudu, so in the way if you are walking along the z direction, okay, so if you are trying to measure what is the distance between ante two peaks మళ్ళీ ఎంత దూరం తర్వాత రిపీట్ అవుతాయి, అదే కదా వేవ్ లెంగ్త్ అంటే. సో ఇఫ్ యూఆర్ ట్రైంగ్ టు మెజర్ వాట్ ఈస్ అ వేవ్ లెంగ్త్ ఇన్ ద జెడ్ డైరెక్షన్, సో జెడ్ డైరెక్షన్లో వేవ్ లెంగ్త్ ఎంత అని మెజర్ చేద్దాం ట్రై చేశారు అనుకోండి, డూ యూ థింక్ ఇట్ విల్ బీ ఈక్వల్ టు లాంబ్డా అంటే నో, ఇట్ విల్ నాట్ బీ. ఇట్ విల్ నాట్ బీ ఈక్వల్ టు లాంబ్డా బికాస్ ద వేవ్ అంటే ఒక యూనిఫామ్ ప్లేన్ వేవ్ ఈజ్ నాట్ ట్రావెలింగ్ ఇన్ జెడ్ డైరెక్షన్. జెడ్ డైరెక్షన్లో యూనిఫామ్ ప్లేన్ వేవ్ వెళ్ళట్లేదు. ఓకే, ఐ టోల్డ్ యూ ఆల్రెడీ. సో ఒకవేళ మీరు వేవ్ వెళ్తున్న ఒక యూనిఫామ్ ప్లేన్ వేవ్ వెళ్తున్న డైరెక్షన్లో వెళ్తే, మేబీ ఇఫ్ యూఆర్ వాకింగ్ ఇన్ ద డైరెక్షన్ ఇన్ విచ్ ద వేవ్ ఇస్ బౌన్సింగ్, ఆ డైరెక్షన్లో మీ వేవ్ లెంగ్త్ అంటే రెండు పీక్స్ మధ్య దూరం అనేది లాంబ్డానే ఉంటుంది. బట్ బికాస్ you're walking in z direction because you want to do the analysis or you want to look how the wave is propagating in z direction, ఆ డైరెక్షన్లో నడుస్తున్నప్పుడు వేవ్ లెంగ్త్ అన్నది ఇట్ ఈస్ డిఫరెంట్. హౌ డు యూ గెట్ దట్ వేవ్ లెంగ్త్? You get it from the phase constant in that direction. So because any phase constant is nothing but 2 pi divided by the wavelength. Okay, so this is the wavelength in the z direction. And I could actually lambda z and write because it's the wavelength in z direction, or because z direction lone guide undi kabatti usually we call it as lambda g. So beta is nothing but 2 pi by lambda g, just like k is nothing but equal to 2 pi by lambda. K into 2 pi by lambda, the wavelength at which you are operating. If at all waveguide walls ఏం లేకపోయిన ఉంటే ఫ్రీ స్పేస్లో అది ఎంత ఫేస్ కాన్స్టెంట్తో ప్రాపగేట్ అదంటే k అనే కాన్స్టెంట్, or it would have traveled at a wavelength of lambda. But because it's in a bounded region, సో ఈ బౌండెడ్ రీజన్లో వేవ్ అన్నది జెడ్ డైరెక్షన్, నేను పర్టికులర్గా ఒక డైరెక్షన్ అడుగుతున్నాను, పర్టికులర్గా జెడ్ డైరెక్షన్లో ఎంత వేవ్ లెంగ్త్ ఉంటుంది అన్నది అడిగితే దట్ ఈస్ డిఫరెంట్. సో ఇదేం కొత్త కాన్సెప్ట్ కాదు నాన్న. ఇఫ్ యూ రిమెంబర్ వేవ్ ప్రాపగేషన్ చెప్తున్నప్పుడు ఇలా తీసుకున్నాను చూడండి, ఇలా ఎక్స్ యాక్సిస్ జెడ్ యాక్సిస్ తీసుకుని, ఫర్ ఎగ్జాంపుల్ ఇలా ఒక వేవ్ వెళ్తుంది అనుకోండి ఎగ్జాక్ట్ ప్లేన్లో. ఓకే, సో దానికి కాన్స్టెంట్ ఫేస్ ప్లేన్స్ ఇట్లా డ్రా చేసినప్పుడు ఈ రెండు ప్లేన్స్ మధ్య దూరాన్ని, ఓకే, ఇక్కడ లాంబ్డా అంటే ఏంటి అంటే ఇఫ్ యూ రిమెంబర్, సో ఈ ప్లేన్స్ మధ్య డిస్టెన్స్ని లాంబ్డా అన్నాను. సో దిస్ ఇస్ లాంబ్డా. అయితే ఆన్ ద జెడ్ యాక్సిస్ ఈ డిస్టెన్స్ అంతా లాంబ్డానే ఉంటుందా అంటే ఎందుకు ఉంటుంది? ఉండదు కదా, ఇట్ విల్ బి మోర్ దాన్ లాంబ్డా. అలాగే ఆన్ ద ఎక్స్ యాక్సిస్ ఆల్సో వాట్ ఈస్ దిస్ అంటే ఇట్ విల్ బి మోర్ దాన్ లాంబ్డా. ఇన్ఫాక్ట్ ఈ వాల్యూస్ కూడా కట్టాం, ఎంత వస్తుంది అంటే దిస్ ఇస్ లాంబ్డా, ఐ థింక్ ఐ రిమెంబర్ సంథింగ్, లాంబ్డా బై కాస్ 5x అంటే ఎక్స్ యాక్సిస్తో చేసే యాంగిల్. ఓకే, అండ్ లాంబ్డా వై అంటే ఇట్ ఈస్ లాంబ్డా బై కాస్ 5z జెడ్ యాక్సిస్తో చేసే యాంగిల్, డైరెక్షన్ కొసైన్స్. సో ఇఫ్ యూ రిమెంబర్ అంటే ఏంటంటే ఈ డైరెక్షన్లో పాయింట్స్ అన్నవి ఇంకా ఎక్కువ దూరం నడుస్తాయి, అందుకని ఈ డైరెక్షన్లో ఫేస్ వెలాసిటీ విల్ బి మోర్ దాన్ ద వెలాసిటీ ఆఫ్ లైట్ అన్నాను. సో ఇన్ఫాక్ట్ ఇది చెప్తున్నప్పుడు కూడా ఫేస్ వెలాసిటీ కాన్సెప్ట్స్ మాట్లాడుతున్నప్పుడు ఈ డైరెక్షన్లో వెలాసిటీ ఆఫ్ లైట్తోనే మూవ్ అవ్వచ్చు. కానీ ఇక్కడ ఏంటి అంటే బికాస్ when the wave has to travel from here to here, it has to just move a distance of lambda, but here it has to travel a larger distance. So andukane if you ask me what is the phase velocity in z direction ante it will be more than the velocity of light ani chepparu. So the phase so andukane ikkada kuda enti ante the wavelength, so it is, so the wave ఏ డైరెక్షన్ లో వెళ్తుందో నాకు తెలియదు వేవ్ గైడ్ లో, బట్ వాట్ ఐ వాంట్ టు సీ is particularly in the z direction how the wave is traveling, and that parameter answer is given by the this propagation constant or this phase constant beta. So from that phase constant I will get how much wavelength is I am having in this waveguide. ఆ waveguide లో వెళ్తున్న ఒక నాన్ యూనిఫామ్ ప్లేన్ వేవ్ కి ఎంత wavelength ఉంది అనేది, that I will get from the propagation constant beta. So the guided wavelength expression is nothing but 2 pi by lambda g. So our lambda g is 2 pi divided by beta. So this is your answer. Okay, so let us see how do I solve this equation. So ఇక్కడ నాకు ఇచ్చిన క్వశ్చన్ ప్రకారం ఏంటి అంటే the at the operating frequencies both waveguides have same guided wavelength. రెండు waveguides కి same guided wavelength ఉంటుంది అంటున్నారు. So if I substitute lambda g here, so it is 2 pi by the propagation constant beta 1 should be equal to 2 pi by beta 2, or simply beta 1 should be equal to beta 2. So that should happen. So what is a phase constant expression? Square root of k square minus kc square for the first one, and the first case should be equal to square root of k2 square minus kc square. Okay. So what I will do is on both sides I'll take uh, k square or k1 square and k2 square common. So I get k1 times square root of 1 minus fc1 by f1 whole square is equal to k2 times square root of 1 minus fc2 divided by f2 whole square, right? So I guess you can understand, you get kc1 divided by k1, so that is nothing but cutoff frequency divided by the operating frequency. So here also k1 ante I can write it as 2 pi square root of because both waveguides are air filled, they didn't give that the medium is different. So I get 2 pi f1 times of square root of mu epsilon naught, and here also I get this is equal to 2 pi f2 times of square root of mu naught epsilon naught. So I can see that the square root of mu epsilon naught part and 2 pi part gets cancels out on both cases. So you're left with an equation like this. So what they have given f1 and f2. F1 is given and f2 is given, and fc1 is also given. They're basically asking you what is a fc2. Okay, of course I can take this f1 also inside and I can write square root of 1 square root of f1 square minus fc1 square is equal to square root of f2 square minus fc2 square. So from here, if I take square on both sides, so basically end up with f1 square minus fc1 square is equal to f2 square minus fc2 square. So this is your equation. So I have to substitute the values here. Okay. So because everything is basically in gigahertz, so don't worry about the gigahertz. You don't have to substitute in gigahertz. You'll get an answer also in gigahertz. Okay. So of course, I said the answer is in gigahertz. So let me put those values f1 and 2 bettandi. So 2 square minus fc1 and the 1 square should be is equal to f2 square and 4 square minus fc2 square. Of course, ఇక్కడ గిగాహెడ్స్ కదా సార్, 10⁻⁹ మిస్ చేశారు ఏంటంటే నేను ఆన్సర్ కూడా గిగాహెడ్స్ లోనే చెప్పబోతున్నాను అన్న. సో ఎవ్రీవేర్ దర్ ఇస్ గిగాహెడ్స్. ఓకే, సో వాట్ ఈస్ ఆన్సర్ ఫర్ దిస్?
Root 13.
Okay, ma, thank you. So root 13. So the answer is root 13. So that is how you get the answer for this question. Okay, so let's move on to the next one. So in a square waveguide, okay, square waveguide lo TE11 mode has an axial field like this. TE11 mode ki hz component etla untado ichadu nanna. So they're asking where the waveguide dimensions are in centimeters. Waveguide dimensions any centimeters lo untayanta. And the question is, what is the cutoff frequency of this mode? If ee mode ki TE11 mode ki cutoff frequency enta అని అడుగుతున్నారు. ఎలా క్యాలిక్యులేట్ చేస్తాం? సో ఫస్ట్ ఆఫ్ ఆల్ TE11 mode ki cutoff frequency formula ఏంటో చూద్దాం. So the cutoff frequency formula is like this: c divided by 2 pi times of square root of mu epsilon by square root of m pi by a whole square plus n pi by b whole square. Okay, అంటే డైరెక్ట్ మీకు ఫార్ములా గుర్తులేకపోతే యూ కెన్ ఆల్వేస్ డిరైవ్ ఇట్ ఫ్రమ్ కేసీ స్క్వేర్ ఇస్ ఈక్వల్ టు m pi by a whole square plus n pi by b whole square అని రాసుకొని మేబీ దిస్ యూ నీడ్ టు రిమెంబర్. ఓకే, అక్కడి నుంచి ఐ కెన్ రైట్ దిస్ ఇస్ నథింగ్ బట్ 2 pi fc square root of mu epsilon is equal to square root of m pi by a whole square plus n pi by b whole square అని రాసుకుని అక్కడి నుంచి ఎఫ్సి ఫార్ములా డిరైవ్ చేసుకోవచ్చు. ఇట్ డజంట్ మ్యాటర్. ఓకే, అఫ్ కోర్స్ దిస్ ఇస్ mu r and epsilon r, అంటే this mu can be written as square root of mu naught into square root of mu r epsilon r. So 1 by square root of mu epsilon naught is nothing but c. అట్లా రాశాను. సో ఇది ఎయిర్ ఫీల్డ్ అనుకుందాం, ఇక్కడ ఏమి ఇవ్వలేదు ఎయిర్ ఫీల్డ్ ఏంటి అన్నది. బట్ వాట్ ఐ కెన్ సీ is because from the equations I can see that it should be like m pi by a and m pi by b లాగా ఉండాలి. Okay, so what is value of a and b? From here I can see the value of a
Root.
is root 8 and value of b is also root 8 because it's a square waveguide. Okay, కానీ of course it's given the waveguide dimensions are in centimeters.
సార్ అట్లా ఎఫ్సి అది కేసీ స్క్వేర్ పైన ఉండాలి కదా సార్, అంటే సి టైమ్స్ అని ఉండాలి.
fc అంటే రైట్, థ్యాంక్ యూ నాన్న. I got. So you get here m pi by a whole square plus n pi by b whole square. Thank you. My mistake. Okay. So because here we are dealing with a square waveguide, a is exactly equal to b. Okay. So b అన్న a అన్న ఒకటే తీసుకోవాలి. So ఇక్కడ a and b values are given. So if you try to find the cutoff frequency, you get an answer here. So ఎంత వస్తుంది cutoff frequency answer? C divided by 2 pi. Maybe it is air filled అనుకుందాము because it's not given here whether it's air filled or not. So if mu r and epsilon r is taken as 1, so you get C by 2 pi, okay, square root of m and 1 అంటే m1 and 1 కూడా తీసుకుంటే you get 2 times of pi by a whole square. Okay, so you get C times of square root of 2 divided by pi by 2 pi into a. So pi gets cancels out. So I can say it is simply C divided by square root of 2 times of a. So C ante 3 into 10 to the power of 8 రాసుకోవచ్చు. So all I can see is if I put a is equal to square root of 8, what is the answer I get?
C sir. 7.5 gigahertz.
7.5 gigahertz. Okay. So you can see there is an answer of 7.5 gigahertz here. ఓకే, సో ఇక్కడ వేవ్ గైడ్ డైమెన్షన్ సెంటీమీటర్స్లో ఉంది అని ఇచ్చాడు, కానీ ఇక్కడ వేవ్ గైడ్ డైమెన్షన్స్ ఏం అడగలేదు. సో యూజువల్గా ఏంటంటే అది ఇవ్వటంలో వాళ్ళ ఉద్దేశం ఏంటి అంటే జస్ట్ కన్ఫ్యూజ్ యూ దట్ వెదర్ యూ విల్ ఫాల్ ఫర్ ద ట్రాప్ ఆర్ నాట్ అని. అంటే ఇక్కడ అఫ్ కోర్స్ ఇక్కడ ఏంటంటే మీకు 7.5 గిగాహెర్ట్జ్ వస్తుందా ఆన్సర్? ఐ థింక్
అంటే ఆన్సర్ అయితే 7.
తీసుకుంటే
సెంటీమీటర్, అదే సెంటీమీటర్లు తీసుకుంటేనే గిగాహెర్ట్జ్ వస్తుంది, లేకపోతే రావట్లేదు. బట్ యాక్చువల్గా ఐ థింక్ దెర్ ఈస్ ఇట్ ఫీల్స్ లైక్ ఇట్ ఈస్ ఎ ట్రాప్ బై సెంటీమీటర్. ఇక్కడ ఆన్సర్ లేనట్టుగానే ఉంటుంది బికాస్ ఇక్కడ ఇంపార్టెంట్ థింగ్ ఏంటంటే ఇఫ్ ఇట్ ఈస్ రియల్లీ ఇన్ సెంటీమీటర్ దెన్ హియర్ దెర్ షుడ్ నాట్ బి ఎ రూట్ 8 యాక్చువల్లీ, బట్ he somehow managed it to give a question like that. Okay, but you should be careful. If there is a centimeter here, there should be 100 here. ఇక్కడ 100 ఉండాల్సిందే. ఇక్కడ 100 ఉంటే అప్పుడు అది కరెక్ట్గా మనకి ఆన్సర్ విల్ బి లైక్ ఇన్ సెంటీమీటర్స్ అని రాసేవాళ్ళం. బట్ he didn't go with that kind of field analysis, simply అక్కడ ఇచ్చాడు. ఓకే, బట్ ఎనీవేస్ it's given, it is whatever is given, we can't change it, but that is not how you should write. If it is really in centimeters, you get 100 here. Okay, right. Okay, we'll move on to the next one. So ikkada an air filled waveguide with the dimension a and b is given has guided wavelength at frequencies f1 and f2. Oh, same indakalage. When operating at t is 10 or t, if the frequency of f1 the frequency of f1 is 13 gigahertz, maybe v13 అని 13 gigahertz, what is the f2 frequency? So ఇక్కడ క్వశ్చన్ ఏంటంటే నాన్న, so the dimensions of the waveguide are given and it is said it is air filled and the dimensions are given. So they are saying that two frequencies of అంటే f1 frequency and f2 frequency which are operated at TE10 and TE20 will have same guided wavelength. అంటే ఏమంటున్నారు, సో f1 అనే ఫ్రీక్వెన్సీలో సే TE10 మోడ్లో ఆపరేట్ చేశాను అనుకోండి, f2 ఫ్రీక్వెన్సీలో TE20 మోడ్లో ఆపరేట్ చేసినప్పుడు నాకు రెండు కేసెస్లోని సేమ్ గైడెడ్ వేవ్ లెంగ్త్ వస్తుంది అంటున్నాడు. సో ద గైడెడ్ వేవ్ లెంగ్త్ ఇన్ ద ఫస్ట్ కేస్, and when you are the first case, and the guided wavelength in the second case is same. So he gave you that the operating frequency f1 is 13 gigahertz. Okay, so if you remember, if I make the guided wavelength same, that means in both cases the propagation constant should be same. So in one case the propagation constant is t, ఇది సేమ్ వేవ్ గైడ్ నాన్న, డిఫరెంట్ వేవ్ గైడ్స్ కాదు. ఇన్ వన్ కేస్ ద ప్రాపగేషన్ కాన్స్టెంట్ ఇస్ t10 mode, and in other case the propagation constant is t20 mode. Okay, so what is the propagation constant in both cases? What is the propagation constant in both cases? And of course ikkada it is operating at frequency f1. Maybe you confuse beta 1 రాస్తాను ఇక్కడ, ఇది beta 2 అని రాస్తాను, so that you don't confuse. They are not operating at same frequency, different frequencies. So if you write it, you get same ఇంతకు ముందు వచ్చినట్టే వస్తుంది. You get square root of f1 square minus fc square, fc1 square is equal to square root of f2 square minus fc2 square అని వస్తుంది. అయితే ఇక్కడ వాట్ ఈస్ fc1 స్క్వేర్ అంటే, వాట్ ఈస్ fc1 అంటే ఇట్ ఈస్ బేసిక్లీ ద కట్ ఆఫ్ ఫ్రీక్వెన్సీ ఆఫ్ t10 mode, so that is c by 2a. Okay, so the cutoff frequency of t10 mode, but what is the cutoff frequency? fc2 is the cutoff frequency of t20 mode. So for t20 mode the cutoff frequency will be what? c by a, right? So it will be double kabatti you get c by a. So we have these values. You can have the value of a and we can calculate the values of the cutoff frequencies. Can you tell me what is the cutoff frequency of t10 mode? So it is 3 into 10 to the power of 8 divided by 2 into 75 mm. ఎంత వస్తుందన్న?
టూ GHz.
2 gigahertz. Okay, so if this is 2 gigahertz, then this will be 4 gigahertz, twice of it. So I think ikkada what I can write is f1 is given, I think f1 frequency is given as 13 giga. So ante 13 square minus the cutoff frequency for the first one is 2 square should be is equal to the second waveguide frequency కనుక్కోవాలి, and the cutoff frequency for the second one is 4 gigahertz square. So ఇక్కడ నుంచి what you're getting answer ఎంత వస్తుంది? 2√13 అనా? ఏమొచ్చింది అన్న? ఆన్సర్ ఏమొచ్చింది? Oh, oh, maybe this is not v nana. I think probably it is √13. Let us take that as √13 and let us check, because ఇక్కడ నేను ఇలా తీసుకుంటే నాకు ఆన్సర్ రావట్లేదు, ఏం ఆన్సర్ రావట్లేదు. మేబీ దిస్ ఇస్ నాట్ v, మేబీ దిస్ ఇస్ స్క్వేర్ రూట్. ఓకే, సో లెట్ మీ చెక్ విత్ ద స్క్వేర్ రూట్. సో ఇఫ్ ఐ గెట్ స్క్వేర్ రూట్ ఆఫ్ 13 హియర్, అప్పుడు వస్తుందా?
5 వస్తుంది.
అప్పుడు 5 వస్తుంది ఆన్సర్. దెన్ మేబీ d is not the right one. Let me check it. So 5 is your answer, right? If you take square root of 13, you get 5. Okay, so answer is 5. Okay, so here is another question. Okay. So here they are asking you that they have a waveguide with these dimensions. Okay. And they want to use it as a high pass filter. అంటే high pass filter అంటే higher frequencies పాస్ అవ్వాలి. యూజువల్గా వేవ్ గైడ్ విల్ సో వేవ్ గైడ్ రెక్టాంగులర్ వేవ్ గైడ్ బిహేవ్స్ యాజ్ అ హై పాస్ ఫిల్టర్. ఓకే, అఫ్ కోర్స్ బ్యాండ్ పాస్ అని కూడా అనొచ్చు, బట్ ఇఫ్ యూ ఆర్ థింకింగ్ అబౌట్ సింగిల్ మోడ్ ఆపరేషన్ వీ కెన్ ఇమాజిన్ హై పాస్ ఫిల్టర్ అంటే కట్ ఆఫ్ ఫ్రీక్వెన్సీ తర్వాతే ఆ ఫ్రీక్వెన్సీస్ ప్రాపగేట్ అవుతాయి, దాని కింద ఫ్రీక్వెన్సీస్ దే విల్ నాట్ ప్రాపగేట్. సో యూజువల్లీ వీ కాల్ ఇట్ యాజ్ అ హై పాస్ ఫిల్టర్. సో నేను ఏమడుగుతున్నానంటే if the stop band attenuation at 8 gigahertz is approximately 109.2 gigahertz, what is the length of the filter? Oh, assume conductor losses are 0. Okay. ఓకే, ఇక్కడ బేసిక్లీ ఏంటంటే నాన్న ఇట్స్ ప్రాబబ్లీ ఫర్ ద స్టాప్ బ్యాండ్ అటెన్యూషన్ అన్నది ఫ్యాక్టర్స్ మీకు ఎట్లా డిఫైన్ చేస్తారో చెప్పలేదు కాబట్టి ప్రాబబ్లీ ఇట్స్ నాట్ ఏ వైజ్ ఐడియా. ఐ థింక్ దిస్ కమ్స్ అండర్ ఫిల్టర్స్, ప్రాబబ్లీ నాట్ వేవ్ గేట్స్. Yes, you can calculate because they are saying that there are no losses. That means they're asking you to consider the propagation constant and the complex propagation constant as your attenuation constant. So if that is what they're doing, then maybe we can calculate the beta value, and from the value of beta at 8 gigahertz, maybe we can calculate what is the attenuation constant. I think that is the only way we can solve it, but maybe we'll see. Okay, maybe if the 8 gigahertz, first of all, అసలు 8 gigahertz అన్నది అటెనేట్ అవుతుందో లేదు. of course it will be attenuating probably. So 15 mm అంటే the first mode cutoff frequency is C by 2a, so that is 3 into 10 to the power of 8 divided by 15 into 10 to the power of minus 3. Okay, so you get 10 to the power of minus 2 in the denominator. Okay, so you can see the 10 gigahertz is the cutoff frequency for TE10 mode for in this waveguide. So what will be the propagation constant? And if you try to calculate beta is nothing but square root of k square minus kc square. Okay, so let us try to find it in that scenario. K and you get 2 pi the frequency. Maybe if I take k common, I get k divided by square root of 1 minus fc by f whole square. Okay, so let me put k and ikkada 2 pi, the frequency is 8 gigahertz, 8 into 10 to the power of 9, 2 pi f into the velocity, I mean k 2 pi f into that is square root of mu naught epsilon naught. Okay, into square root of 1 minus what is fc అంటే 10 gigahertz, and the frequency of operating is 8 gigahertz. So giga cancel అవుతాయి, so you get 10 by 8. So what you get for this, దీనికి ఎంత వస్తుంది ఆన్సర్? You need to get an imaginary number. You'll see how you'll get it. So ఇక్కడ 2 pi into 8 into 10 to the power of 9 mu naught epsilon naught అంటే I can write it as 1 by 3 into 10 to the power of 8. So I can see you get a 10. So you get 160 pi by 3 times what is the square root of అదంతా వస్తుంది. So if I write it as square root of 1 minus 10 divided by 8 whole square, you get 0.75 J. Okay.
125.6J.
ఎంతన్నా 120
5.6J. 125 sir.
125
Yes, sir.
5
0.6 J.
J. Okay, so this is the value of beta we get. Okay, of course ఇక్కడ square root అన్నది I can take it an attenuation or I can think of it as an evanescent mode. So ఇక్కడ నేను filter analysis మాట్లాడుతున్నాను కాబట్టి if I assume that this is the value of alpha I get, okay, so maybe if I assume the alpha is 125.6 nepo per meter, so if I want an attenuation, because usually the amount of attenuation you get is e power minus 2 times of alpha z laga untadi. Okay, so here they say that for a given length, okay, if the stop band, if I want an attenuation of minus 102.9 dB, ఇంత dB attenuation కావాలి అంటే how much length I have to choose, ఎంత length choose చేసుకుంటే నాకు అంత attenuation వస్తుంది అని అడుగుతున్నాడు. So if I take 10 log for this, 10 log of you get 2 alpha times of, say if I take some length L, so I'm asking you, I want this to be equal to 109.2. Okay, so ఇక్కడ ఎంత length తీసుకుంటే, so ఇక్కడ alpha value is given, so it is so I have 10 log, if I assume 2 times of 125.6 L అని తీసుకుంటే ఇక్కడ నుంచి I need the value of answer for what is the length, ఎంత వస్తుందన్న length. So I can divide it by 10, so I can say 109.2 divided by 10. Okay, so you take 10 power that value, and then I think you need to divide it by
39.10 power 6 sir. 39 to 10 power 6.
okay, so it's basically a very big number, huh? Okay, so I think ఇక్కడ attenuation అన్నది I think I didn't define it properly. I think maybe it is not e power minus 2 alpha which we need to take here. They have taken something else. Probably power attenuation తీసుకోలేదు అనుకుంటా.
Sir, attenuation is in dB అంటే dB లో
Attenuation.
నెపర్ లోకి కన్వర్ట్ చేయాలి కదా, కన్వర్ట్ చేశాను.
మనకు ఆల్రెడీ ఆల్ఫా అన్నది I think it's we got that answer already in okay, maybe they're asking for alpha itself. Okay, I look into it. Probably I'll go to attenuation constant another, because it's a filter. We need to define the attenuation constant differently, but we should not consider it. I think attenuation constant formula in the prasna. Maybe I'll get back to you regarding the attenuation constant here. I think it's something related to the filter design. So probably it's not the concept which we will get it here in our waveguide analysis. So I'll look into this attenuation constant, what kind of constant they are taking and all. Okay, maybe we'll solve it. I'll get back to this in the next session again. Okay, maybe we'll solve the next problem. Uh, a cylindrical waveguide with a radius of 3.5 centimeter has a wave traveling of TM12 mode. Okay, then the value of first 0 and the second order Bessel's function is 7. Uh-huh. Find the cutoff frequency. They have given you the 0 for the second order Bessel's function. So ఇక్కడ ఇచ్చింది ఏంటో చూడండి, TM12 మోడ్ ఇచ్చారు అంటే n is taken as 1 and the root, so root value is 2. So the cutoff frequency formulas ఏమొచ్చాయి మనకి for TM mode or so. The cutoff frequency formula, if you remember, cutoff frequency కాదు, KC formula ఎంత వచ్చిందంటే KC was the root value divided by 2a అని వచ్చింది. Okay, so what is the root value here? The value of the root is given as 7. Okay, I think what they're asking what is the cutoff wavelength. So a is also given, which is 3.57 centimeters. I think k, so that gives you the answer for this, which is 1 centimeters కాబట్టి 100 వస్తుంది. ఓకే, సో కేసీ ఎంత అన్నది కావాలి. దిస్ ఇస్ కేసీ, నాకు కట్ ఆఫ్ వేవ్ లెంగ్త్ వచ్చింది, నాకు కట్ ఆఫ్ వేవ్ నెంబర్ ఇది. కట్ ఆఫ్ వేవ్ లెంగ్త్ అంటే 2π divided by lambda c is the cutoff wavelength. So this should be equal to 100. Okay, so I can say lambda c is nothing but 2π divided by 100, or that is nothing but 2π centimeters. So your answer is C. Okay, so that is how you solve this question. Okay, so that is, I think these are the bits from ISRO questions. I think except this question we have solved all the questions. Maybe in the next session I'll talk about this question also. I'll get the definition of attenuation constant that is used in the filters so that we can solve this question also. Okay, చెప్పండి అన్న.
సార్ కేసీ పిఎన్ఎం బై ఏ కదండి సార్?
ఓ పిఎన్ఎం బై ఏనా? ఓకే, మై బ్యాడ్. I think I have rectangular waveguides లోకి వెళ్ళిపోయినట్టున్నాను. Yes, you're right. So KC is PM by A. So my bad. So you get 200 here. Okay, so if you get 200, then you get an answer of pi. So it is pi centimeters. So your answer is A. Thank you, Nana. Thank you very much. So the KC for this TM mode is that root divided by A. Okay, so that root value is given as 7. Okay, right. So the next part is about some questions in the DRDO, and after that we'll talk about the questions related to gate. So we'll do it in the next session. Okay, so if you have